Alright guys, last lesson for Unit 3. And we're going to be graphing piecewise functions today. I'm going to give you one and your job is going to be to actually graph. Before we begin, let's review some facts about inequalities here. When you are graphing on a number line, so for instance, if I told you that x is less than 3, and if you were to graph that on a number line, right, you would use an open dot for that, okay? Because that means that x cannot equal 3, but it goes up to, but not including 3. Now, if you put an equal sign underneath, it goes up to and includes the 3, and in that case, we do a solid dot, okay? So just a quick little reminder there. No equal sign underneath, we use an open dot. Equal sign underneath, we use a closed dot. And let's not forget also that x is greater than a means that this symbol means x is greater than a. And I gave you guys a way of remembering that last time, which is thinking of that as Pac-Man. He always wants the bigger number. So this is x is greater than a, whereas this would be x less than a because it's not. Okay, so just some basic stuff there to review about inequalities. So we looked at this picture last time, and just to review, a piecewise function is a single function comprised of various other pieces put together. So I'll just call these the pieces. And right here, these are the intervals that those pieces exist on. So for instance, the equation negative x plus 1 exists on the interval for all x less than negative 2. So that's this one. As you can see, it stops at x equals negative 2. So that is the function negative x plus 1. And then after that, the piecewise function turns into this one, which I'm going to use a different color for that. So it's a square root function. And the square root function exists on this interval. So from negative 2 to 4. Now there's nothing from negative 2 up to negative 1, but from there it goes over here. And then finally we have the last piece, which is x minus 3. And that's for everything where x is greater than 4, and that's this line here. So we have the pieces and the intervals, and altogether it's a piecewise function. So we're going to be graphing some of these right now. I'm going to give you guys some steps to follow as you do this. It takes a little bit of time, but it's not that bad. Not that bad. Matter of just plugging things in and connecting some dots. That's all. So I'm going to erase number 2 for now, so I have some space. All right, so I'm going to give you guys some steps as we go through this process, and I would encourage you guys to include the steps in your notes, but you certainly don't have to write these. All right. So here we go. So step 1 is to pick some values for x. For each piece. And when you do that, you want to make sure they are in the interval and include the endpoint. Actually, we'll say start with the endpoint. So let me explain what I mean by that. Okay. So for the first piece that we're looking at up here, x plus 1, it exists on the interval for all x less than or equal to 2. So what we're going to do is we're going to pick some values for x that work for that. And you always start with the endpoint. So I'm going to start, this is the endpoint, and you'll see why we call it an endpoint when we get to the end. But for now, we're going to start by using the number that they give us, which is 2, comma, and I'm going to leave a blank next to it because we need a y value that goes with it, and we'll get to that in a second. But we need at least 2 more points, and I probably should have put that in my directions here. So let me modify my directions. pick some values for x. I'll pick 3 values for x because we want to do at least 3 values, I would say. Okay? And for some reason, my writing got sorry. There we go. We're good. So we want to pick 3 values for x. So I picked the first one, and you always start with the endpoint 2. But let's do another one. Now these other 2 points have to be in the interval. So you have to be able to read this. This says x is less than 2. So we need to pick any values for x that are less than 2. So remember, we start with 2, but then we need 2 more points that are less than 2. And so some good natural choices there would be like 1 and 0. So pick 3 numbers that are in the interval and always start with the endpoint they give you. Okay? Now the next thing I'm going to do is I'm going to find the y values by plugging in the x's. Find the y values by plugging in the x's. So what do I mean by that? Well, I'm going to take this value for x, I'm going to plug it in right here to this function. Okay, so I can find the y value that goes with it. So if I plug in 2, I get 2 plus 1, which is 3, and I'm going to put my answer right here. Okay, so that's what I mean by find the y values that go with each one. We're going to plug in the x value and get the y value that goes with it. So we got 3. Now let's plug in the next x value, which was 1. I'm going to plug in 1. If you plug in 1, 1 plus 1, which is 2. And then we're going to do one more. We're going to plug 0 in here. And 0 plus 1 gives me 1. So I've got my 3 points. Now, we're going to repeat that for the other one down here. So we have another piece that we need to do that for. So we'll do that now. So let's go ahead and do that for this next piece. So now we want to pick numbers that are greater than 2. But once again, you always start with the endpoint. So I'm still going to include 2 there. But now I want to pick 2 other points that are greater than 2. So what are 2 values that are greater than 2? How about 3 and 4? And once again, we're going to plug in the x values to find the y values. Now here's something weird. We don't have an x to plug into. Okay, so in this case, you can't plug in 2, 3, or 4. The answer is always 1. So it doesn't matter what the x values are. In other words, the output's always 1 for this one because there's nowhere to plug the x in, and so the x doesn't ever affect the answer. So the y value is always going to be 1 for that piece. Okay. All right, so that's the first 2 steps. So pick 3 x values for each piece. Make sure that they're in the interval, and you always start with the endpoint. In this case is 2. And then you find the y values by plugging in the x's. Okay. Now we're ready for the next point. The next step, I should say. The next step is to decide if the endpoints are open or closed circles. Okay, so we talked about in the last slide, one of the last few slides that is, that whenever you have less than or equal to, it's a closed dot. So for the endpoint 2, 3, we're going to be using a closed dot. So I just like to put my dot here just so I remember that when I'm graphing it. Now for the other piece down here, we have the other, this is also an endpoint. So this is the starting point for, or maybe I guess we say it's the end point for one piece, and this is the starting point for another. You'll see what I mean when we get there. But this is the end point for this piece down here. So we also need to decide, is this an open or closed dot? Well, for this one, x is greater than 2. Can't be equal though. So in that case, we're going to use an open dot because what that means is that this point actually doesn't exist for this piece, but we're going to use it as a boundary, as a starting place, but it doesn't actually exist. Whereas for this one, it's a boundary point, so we'll start there, but it also actually exists on this function. So closed dot versus open dot, that's step 3. It's an equal sign underneath closed dot, no equal sign is an open dot on the endpoint. The last thing that we need to do is just graph it. Okay. I'm going to put don't forget the arrows. You'll see what I mean by that in a minute. Okay. So here we go. Let's graph. Okay. So I'm going to start off with this one here on top, this piece. Let's graph this piece first. So we're going to do 2, 3. So over 2 and up 3, and I'm going to use a closed dot because it for my endpoint of 2, 3 because that's what we decided it was. Next point is 1, 2. So over 1 up 2. Next one is 0, 1, which is right here. So there's my 3 points. Now, here's how we do the graphing now. We want to connect these dots, but you always start with the endpoint. So this one up here, the big thick one, that was my starting point. So I'm going to start there, and then we draw a line through the other dots, and we don't forget the arrow. So I think maybe now that I've said that, I'm going to go back now, and I'm going to add something to my steps. I'm going to say, sorry, I didn't want to do there. There. All right. So start with the endpoint. Start with the endpoint, connect the dots, and don't forget the arrows. So we started with the endpoint, 2, 3, we connected the dots, and we don't want to forget the arrow. Okay? So now the next thing that we're going to do is we're going to go ahead and graph the next piece, which I'll highlight in pink here. Once again, we start with the endpoint, 2, 1, so over 2, up 1, and this time it's an open dot. Then the next point is 3, 1, so over 3, up 1. And the next one is 4, 1, or 4, up 1. And once again, to graph this, we start with the endpoint, we connect the dots, and we don't forget the arrow. So there's the graph of the piecewise function. The green one is the top piece, x plus 1. So that's the line x plus 1, and that's the part of the function for all x that's less than 2. Okay? The pink line down here is the second piece, and that's the equation, that's the graph of the equation y equals 1, and that's the piece that we use for all x greater than 2. So there's our piecewise function. So just to kind of review the steps again real quick, pick 3 x values for each piece, make sure they're in the interval, and start with the endpoint. Find the y values by plugging in the x's. Decide if the endpoints are open or closed circles. Step 4, graph it. And when you do, you start at the endpoint and connect the other dots, and don't forget the arrow. Okay? So we're going to repeat those steps for this next one as well. Now this is a there's a lot of steps here and a lot of places to kind of get lost along the way. So for this particular example, what I'm going to encourage you guys to do is do these problems yourself, one step at a time with me, okay? That would be my encouragement to you. Of course, you don't have to do that. Sorry, I'll come back to that in a second. I'm going to move all my steps up. I'm in my way. All right, back to this example. Okay, so I would like you guys to pause the video here and see if you guys can do the first step for this first piece only. Only do the first piece. We'll get, actually, you know, once you guys do the first piece and the second piece. The middle one's kind of weird, so hold on to that for a minute. But for now, do the top and the bottom one. Do step 1. Pick 3 values for x for each of those 2 pieces, and make sure they're in the interval and start with the endpoint. When you unpause the video, you'll see the solution. Okay, so here's the answer. So for the top piece, we start with -1, and then we want to pick numbers that are less than -1, so that would be things like -2 or -3. For the bottom piece, we start with the endpoint of 1, and we want to pick numbers that are bigger than 1, like +2 and +3. So now technically it doesn't matter what you guys picked for these other 2 points, the 2 and the 3, but you had to have -1 here and you had to have +1 here. You always include the endpoint. But so long as you pick something that was less than -1, it didn't matter what you picked after that. Maybe you picked different numbers, but most of you guys probably just picked these ones because they're in order. So while we were on that note, I'm going to tell you, I want you guys, no matter what you picked, I want you guys to change these two to certain numbers, okay? Here's what I want you guys to change them into. Even though I put 2 and 3 just because I'm sure most of you guys picked it, and you're not wrong to write that. But because of the next step, and you'll see why in a minute, it's going to be better if we pick some other numbers, and you'll see why when we get there. So for now, just follow my lead. But I'm going to pick something else that's bigger than 1. Instead of 2 and 3, I'm going to pick 4, and I'm going to pick 9. Some of you guys may already be seeing why I chose those numbers, but if you don't, it's okay. Now, I want you guys to, but before we get on to step 2, actually, we still need to do this middle piece. I almost forgot about that. So now what's weird about the middle piece here is that there are 2 endpoints, okay? So we're still going to have 3 points. It's just that we have 2 endpoints. So I need to include the -1 on the left and the +1 on the right. And what this inequality means is that x is bigger than -1, but it's less than +1. So that means that x is anything between those 2 numbers. So for my third number, I can pick anything that's between those 2 values. So that would be 0. Okay, so now there's that. Now I want you guys to pause the video and do step 2. And when you unpause it, you'll see the solution. And you'll also see why I picked 4 and 9. And there's your answers for that. So for the first one, since there's no x on the top, it doesn't matter what the x values are. The y value is always 2. So it's 2, 2, 2 all the way across. For the middle one, plugging in -1 would give you 2, because when you square negative, it becomes positive. So you have +1 plus 1, which is 2. Plugging in 0, you get 1, and plugging in 1, you get 2. Okay. As for the bottom one, you guys can see why I chose 4 and 9 now, because we have to take the square root of whatever we plug in. So when I plug in 1, the square root of 1 is 1. When I plug in 4, the square root of 4 is 2. And when I plug in 9, the square root of 9 is 3. So there's my points. All right. Now, we need to decide if the endpoints are open or closed. Now go ahead and pause the video, and I want you guys to put a closed dot above each endpoint that's closed, and put an open dot above each endpoint that is open. And I'll give you a reminder here. You actually have 4 endpoints that you need to decide open or closed on. All right, so for the point -1, 2, that's an open dot because there's no inequality. For the middle one, we had 2 endpoints, the -1 and the +1. Both of those have equal signs with the x. So both of these ones are going to be closed dots. And then finally, for the square root function down here, the inequality does not have an equal sign. So this endpoint of 1, 1 is going to be an open dot. Now we're ready to graph it. Okay. I wonder. So see if you guys can graph it. Pause the video and see if you can graph it. If you can't, I will walk you through it when we get there. Pause the video, see if you can do it. When you unpause it, I'll walk you through it. All right, so let's go ahead and graph it. First of all, I'm looking at all my points here, and I see that the biggest y value that I can see there is a 2. So we don't really need to go very high for the y values, but the x value goes all the way out to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we're going to start plotting these. So I'm going to do the first piece up here, these 3 points. So I'm going to start with -1, 2, and that's an open dot. And then we're going to do -2, 2. That's just a normal dot, and then -3, 2 is another dot. And now to connect these dots, we always start with the endpoint, so that would be the open dot there. And then we draw a line through the rest of the dots, and we don't forget the arrow. So your arrow for the first piece should look like that. Now for the next one, we're going to start at -1, 2, and that's a closed dot. Now, we already plotted that point, didn't we? -1, 2, and that was an open dot. But now that it's closed, we're going to go ahead and fill in that circle now, because even though that point wasn't an actual point on the first piece, it is a point for the second piece, and therefore that dot gets filled in. So we have -1, 2, closed dot, followed by 0, 1, which is right here, and then followed by 1, 2, which is here, and that's also going to be a closed dot. And we're going to connect them. Now, a lot of you guys, if you've already done this, you probably connected it with a V because that's what you're used to, because we've been doing absolute values. But this is actually a quadratic, and you would actually connect it with a nice smooth curve. But if you didn't do that, don't worry, I wouldn't take points off, you're fine. But technically it would be a nice smooth curve because this is a quadratic, and quadratics are parabolas, right? The ones that look like a V shape, those are absolute values, and that's not what this one is. But like, it doesn't matter if you made it a V shape or a U shape, I'm okay either way. All right, moving on to the last part there, we have to graph this. So we're going to do 1, 1, so over 1, up 1, and this time it's going to be an open dot. Next one is 4, 2, so over 4, up 2. And then, 9, 3, so over 9, up 3, or first go behind it. Over 9, up 3 be here. And so, depending on how well you graph this, you may have noticed that this is not a straight line. It's actually slightly curving. It looks like that. Don't forget your arrow. That's what that particular piecewise function would look like. And there's our 4 steps. So, once again, that's the 4 steps you guys use to do these things. Here are 2 problems for you. I'd like you guys to go ahead and see if you guys can graph these 2 problems. Take a minute, pause the video, and go as far as you can. Okay, go ahead and check your work here. I'll let you guys check your points. So for the first one, we should have had a closed dot at -3, 5 and an open dot at 0, 1. Now notice there's not going to be any arrows on this piece because it has endpoints, okay? Now the next one, I should have told you about this before I made you go, but that's okay. So if you struggle a little bit, it's not a big deal, but it just tells you x equals 0. So what that means is you only have 1 point. It's not an interval. It's not like x can be 0 and then something else. It's 0 and that's it. So x equals 0, the y value is 0. So you just have a dot at the origin there, 0, 0. That's it. As for the next one here, starting with the origin, or I'm sorry, the endpoint of 0, -3, that's an open dot. After that, you plot your other 2 points, and you should have gotten like a parabolic looking shape here. So your final result would look like that. Now for number 2, you have these outcomes, pretty straightforward. Once again, though, we have the same dot twice, 0, 0, in 2 different spots, and one of them's filled in. So ultimately, because the point is repeated and it does get filled in eventually, we end up with just a solid dot there. And they're straight lines with arrows. They just keep going after that. And in case you guys didn't notice, that's just the equation of an absolute value function, right? And if you guys wanted to do what we did last class and turn the absolute value function into a piecewise function, that's exactly what it would look like. Okay, so just drawing some ends together there so you guys can understand things. One more topic before we call this lesson quits. We need to know how to evaluate piecewise functions. So find the missing value. Okay. I don't like those instructions. I'm going to change the instructions. Wrong. It's just a little bit weird. I'm going to say evaluate. That's a better way to describe this. Nope, don't want that color. There we go. Evaluate each expression below. And it went away. Where did it go? Okay, just a second. Okay, so got that. So evaluate each expression below. So basically what that means is we're going to plug -1 into this piecewise function. We're going to see what we get. Now, the trick here is knowing where do you plug it into, okay? Because there's 3 different pieces. Which piece do you use? So you have to ask yourself, which interval is this number in? So -1. So is -1 less than or equal to -4? Is -1 between -4 and 2? Or is -1 greater than 2? So you have to decide what interval that number's in. And hopefully you guys know the answer is -1 is between -4 and 2. And what that means is that we're going to therefore use this expression. So what I'm going to do is I'm going to draw a little arrow from number 1 to here, okay? And I guess in answer to this question up here, I can put what interval it's in. Okay, so I'm going to use this particular piece here, since -1 is between -4 and 2. All right, so we have the square root of negative parentheses x, but instead of x, I'm going to leave it blank because I'm going to plug in a -1. So we have a negative from the actual formula itself, but I'm also plugging in a -1. So we have double negatives, and the answer is 1. Okay, so let's do the next one, g of 2. So which interval is 2 in? Is it less than -4? Is it between -4 and 2? Or is it greater than or equal to 2? You think for a minute, which piece would this one go into? Well, hopefully you know it's this one. Now, what's confusing about this one is that it's 2, and there's 2 in 2 spots. We have it here, and we also have it here. But which one of those spots is x actually allowed to equal 2? That would be the bottom one, because this one, x can't equal to it. It has to be less than 2. So we have to use the one that's actually equal to in that case. So for that one, we're going to use the middle piece. I'm sorry, the bottom piece. So we rewrite the expression, but with a blank instead of an x, and we're going to plug the number in that we want. And so 2 minus 1 is 1, and the absolute value of 1 is 1, and so there's our answer for that one. Last one, what piece would we use for the last one? Plugging in -5, and not surprisingly, we're going to use the top piece, because -5 is less than or equal to -4. So now in this case, there's nowhere to plug the 5 into. You can't plug 5 into a number. That doesn't make sense. So the answer is, just like we said before, that's just the answer no matter what. So for all x less than or equal to -4, the y value, the output, is always going to be -6. It doesn't matter what the x value is. All right, so let's review really quick. Once again, look at the x value, decide which interval it's in, and use that piece to plug it into. Okay? You've got to pay attention. If the number they're giving you is a boundary point, then you will see it in 2 spots, but you've got to pick the one that has the actual equal sign on it to plug it in. Finally, we had the situation where there was no x to plug in for, so we put the number that they gave us. There you go. So I'm going to let you guys try evaluating some piecewise functions. Once again, I don't care for those directions very much. I guess I'll rewrite them again. But the point is I want you guys to evaluate each expression. So when you I'll pause the video here, give it a try, and when you're all done, pause the video and you'll see the solution. And there you have it. So I drew some arrows to show you which piece to use. So for the first one, g of 0. 0 is between -1 and 3, so we would use the middle piece. And if you plug 0 in for x and solve, you'll get 4. For number 2, we're doing g of 4. G of 4 would go into the bottom piece because it's greater than or equal to 3. And so if you plug 4 in, the absolute value of 4 is 4, but there's a negative in the front, so it's -4. And then finally, for the last one, we're plugging in 3. Now 3 is a boundary point, so you see it located in two different places. One's here and one's here. But we plug it into the one where it can actually equal 3. So that's not this one, but rather the bottom one again. So if we plug in 3, we get negative. Okay? And so that is how you graph and evaluate piecewise functions. And that's it for Unit 3.